In this video, I'm going to explain how you can model the Confluent park in Grasshopper, and as you can see, I can change these parameters and define different models of this Confluent park form. As you can see here, I can change this, and I can change here again. And here we go, you can see the model, and we can also change the height of this, so maybe we can just change this a little bit. And as you can see here, we can just produce a deeper curve for the main model. Okay, so first of all, I'm going to explain how we are going to model this and start from scratch. So first, what I'm going to explain is, let's just get the plan of this. And as you can see here, the first thing you can do is to check out the base model. As I explained this in the brainstorming section, the best thing we can do is to find the base model in the thing you can just want to model. So let's just check this out. If I pick this one as the base, you can see that this has rotated here to the top, and what it is that it's an array polar around this point. So you can see that we have 4 of this here, and then we can just delete those sections we don't want. So if I just draw these lines, you can see that this is a polar array of this. Okay, and we can go here, and we have this here. So you can see that this is basically a simple polar array of this model here, the main polygon here, and then we can also again have another polar array here and have this one, this, and again these 4 polygons. So what is important about this polygon is, let's just zoom in. I'm going to zoom in and show you the most important thing we have here. Okay, if we have 4 of these around this point, the most important thing is to have a 90 degrees edge here. This is the first point and the first tip we have to make in Grasshopper. The next one is, here we want also another polar array to have 4 of these at this corner. So again, we need a 90 degrees here too. And what happens is that we can also play with the other edges, but remember we have to have the same length here as we have here, because when we have to polar array this, we have to stick this around. So the first thing is to have, let's just make this with blue, we have 2 edges here, and then we have also 2 edges here which are the same, and again these are the same as these ones, and we can play with this edge, and it doesn't really matter about this one. We can play with that, and we can just change the lengths and have different ones. So the first step, it's just going to take a while to make this polygon. So let's go to the Grasshopper and start making that polygon. We can go to the curve and use the STL, line STL tool, and let's just go and put the bifocals here, and I'm going to extract this and set this to 0, and I can simply draw 2 lines in the X and Y direction. So let's just draw this. 25.6 really doesn't matter, but this is the first line. Then we have another STL, and this time it's going to be in the Y direction. So here we go, we have this 2 lines. What I'm going to do is you can do this different ways, but what I'm going to do is to draw the same length here and then rotate it around this point. So it's going to be something like this, and then we can simply connect this to this end point of that line. So this is going to be easy, but we have to use some tools here. So let's just do this. Go to the curve section, and what I'm going to use is the point on curve tool, and let's just put this on here, and again we can use the SDL, start direction length, from starting from here in the, okay, we can use this in the Y direction. We can use this in another way, but I'm just using the tools to show you we can draw this. Okay, again, another point on curve at the end, and another SDL in the direction X, but this time in the minus X direction. So just let's give this an expression, minus X, and the same length. Okay, why did I do this? Okay, I didn't give that to the length, so let's just give this to the length, because I want to rotate this line around this point. So we're going to go rotate 3D. Let's just join these curves. So I'm going to use join curves, join these two lines to produce this section, and then rotate this around this point. So we can just go rotate this. The center of rotation is somehow starting from here, and the axis is Z direction. And here we go, we can give this a degrees. I've explained that because we can't use degrees here, we have radians, but I just converted that to the degrees. Okay, so maybe we have 0 to 60 degrees. I don't really know that. Let's just see. Okay, it's rotating inwards, so we can give this a minus X to make it outwards. Okay, and just we turn this off, and here we go. You can see that we are producing this, and we have it 90 degrees, and then we have to connect that to the start point. So let's just make a line from 2 points. The starting point will go from the end of this, so another point on curve. Okay, from this line, the end of this, and this is the start of the line, and then we need the end of this one. So let's just go here, another point on curve, and put this at the end. Here we go, and we have the line, and then we can connect them all together. Remember, we have to make them into one polygon. So this is the first line, the second line, the rotated line. Let's just go here, the rotation, shift, and again the line. And let's just check this out. The problem with this is that they are in two groups. We have to flatten them so they can be joined together. Let's just flatten this, and we have 4 lines. Okay, and here we go. We can have this parametric base polygon here, which is 90 degrees here, 90 degrees there. And if I use the array tool, just to show you the polar array tool, the center is this. That's okay. 0, 0, 0. This is the base is here, and we have 4 of them. So the count is 4. Okay, here you can see that we just produced. This is the first step. Let me just make this in a group, and we can change this. You can see we can change the size of this. We can change the rotation, and what else can we change here? That's it. And the thing we can do is to again use another polar array here. So I'm going to, let's just ungroup this. Use a point here to polar array all of this again here. I want to show you the base polygon. This is really important, so we can have a parametric modeling of this Confluence park. So I'm going to again, let's just polar array this again, and again I have to give this a plane at here. So let's just turn this off. I want to find this point, so let's just do this. We can go and go into the rotation. We just rotated this. Okay, let's just explode that into 2 segments, and just by the list item, we know that the list item tool will just pick an item, the first one. Yeah, we have 0 and 1, so that's the 0. And again, let's just go to the point on curve and pick the end. Here we go. Okay, or we can simply use those vertices. I think that's better, so let's just go to the vertices and pick one of those. So again, list item 0, 1. Okay, so that's 1. Here we go. And this is going to be cool if I give this to the plane. Remember, there's a shortcut here. If you give a point to a plane, what happens is that Grasshopper thinks that it's an XY plane. So that's okay, because we are just doing this in the XY plane. So I gave this to the plane and just turn this off. Again, we have 4 of this, and just look how crazy this is. We just made a parametric base here, which we could just change the size, change the rotation. This is really cool. You can see how we can use the geometric constraint here to produce a tessellating polygon that is really crazy, and we can make this on, and we can just have this an array. You can just array this and put that in this direction. So for those who want to make this that is not definitely the Confluence Park, but this is the base of the Confluence Park. So you can also use this as a pattern. If you want, you can just array this in this direction, and simply the 90 degrees from that, you can just have that as an exercise. So let's just do this. I showed you here how we can just make this happen. So let's just delete this. That was the first step. I just wanted to show you that we can produce that. Okay, so here is the first part of producing the polygon, and I'm going to give this as a curve and start from here. So remember, this step is to produce the polygon as a parametric result, and you can see it. For those who just sent me some of their definitions, they started with a 5 polygon, 5-sided polygon, and that's really that's okay, but you're gonna have some problems with that. So remember, this tip can help you to make a parametric polygon which just has tessellating opportunities, because it has 90 degrees and can just have 2 arrays. And this is a really cool technique. You can also use this. I'm going to show you in the future. We can play with this. This is a symmetric mirroring planes, which we can play with that in the future, and this is really crazy. I love that paneling techniques we can use. I'm going to teach you about it later in the future. Okay, so let's just go further. To produce that Confluent Park, let me just show you the pictures, and let's just zoom back in and go here. What can we do to produce that base model? So I'm going to look at a better picture here. Maybe this one is, yeah, okay, that's okay. So assume that this is the circle at the center, and we just saw that here. Let's just go back. This is the circle. How can I just show you the circle with this software? Okay, so it's a tab key. Then what I'm going to do is to connect a line to the circle, and let me show you in Rhino. What we need here is a circle exactly at the center. Then what I'm going to do is to draw a line to here, which is basically at the center, and again a line which just extends to the center. And I'm going to move this line up. So this is basically moving this up. And assume that we produce this pattern. Tangent here goes down, again comes up, a tangent here. And this is great because the neighbors will also have the tangent here come down, again up, again a tangent here, come down and go up, tangent here and go down, and this will produce the result. So one of those is this one. Then we're going to connect here to here and here to here with an arc which starts like this, and again which starts like this, and then we have the results we need. This one, this one, this one, and a simple arc which we can produce the surface, and we're good to go. It's going to take some time, so just stay tuned. And I'm going to give a center to this, and let's just draw a circle. So I'm going to the curve, and that's a circle, and we can define a number here, so that's going to be big. So let's just make this to 5 and make this a little bit smaller. Okay, so to produce that in a parametric way, what I'm going to do is to explode them. So let's just explode the polygon, and we can just turn everything off from here. Okay, and this is the segment. So you can see we have 5 segments: this one, this one, this, and this, and this. And what we're going to do is to go to the curve section and use this endpoints. Here we go. We have the start and the end of each of those segments, and then we need to project them onto that circle. So we're going to just use a project. That's a project point. Let's just do that. A project point. The start of this, assume that we are working with this. The start of this or the end doesn't really matter. We have to project this in the direction to the center. So this is going to be easy. I'm going to go to the direction, going to the vector section and use a 2-point vector to make the direction. So the starting point is going to be the start. The ending point is the center. And so this is the direction. And what are we going to project that point on? It's the circle. Okay, so you can see that this is going to project on that circle, and we can simply draw a line if we want to, but we don't need it now. But we can see that if I connect the start to this projection, we have those lines, but we don't really need that. We need those points to draw that circles. Okay, so again, I'm going to project another point, and that is the end point. So we have to project, assume that this is the line, we have to project the start and the end of each of those lines on that circle. So again, we're going to project the end. The direction is going to be the end to the center, so this is going to be end to the center, and that's it. So we have 2 sets of points, but if we want to draw the arcs for that, we need another point, so we have to use that. Let's go to the primitives, and we're going to use the circle 3 points. So, excuse me, the arc 3 points, because we need an arc. That's a complete circle. Okay, we can give 3 points to produce an arc. So this is the first, this is the second, and where is the next point we are going to use to produce that arc? And here we go. We can simply go back and extract, let me show you, extract the center of this line and project that on the circle, and here we have 3 points to produce the arc. So that's going to be simple point on curve. Let's just extract the center of these, and again another projection. So the projection now goes to the center of this. The direction is going to be from the center towards the center of the circle, and we have 3 points for that arc. And let's just turn everything off. We have this polygons. Okay, so this will help us to produce the arc for each of those sections. So let's just go to the primitive and use the arc 3 points, the start point of arc, the point on arc interior, and the end point of arc. So here we go. This is the start. This is the end, because we just projected the start and the end, and here is the interior. Okay, I just gave this to this point C, and this is the interior. Okay, and to check this out, we can simply bake this and check it in Rhino. So this is the polygon for this line, this is the polygon for this, excuse me, the arc for this segment, this arc for this segment, and so on. Okay, so we made this arc, and I explained that we have to move these lines up and just simply make a tangent, curve like this, and another one will just go from the start to the end and start to the ends. So let's just go, we just finished this one, let's go with these 2 ones so we can have them. And what I'm going to do is to simply move the start and the end up. So let's just do this, move. You can see that this is simply the same thing you have to do in Rhino, but we are doing this with the tools in Grasshopper to make it parametrically. So let's just go in the Z direction, and this is going to be the height of the Confluent Park. So let's just make this a number, and here we go. We can move this up, maybe something like 3 to 20 or 30, doesn't really matter. Okay. And now I'm going to produce that arc to this. Let me show you better here. It's going to be something like this. Okay. Another primitive curve we can use is the arc SED, start end direction. So we're going to use this for these two parts. Show you on the pictures. Okay, I think this one is better. Okay, we produced this section. Now we need these two parts, and at the end we are going to make this one. So here we go, another SED arc. The start is going to be those points. We have to, let's just turn the center off. Don't need this one. Okay, so the start of the arc, the end of the arc, we have the start, the end. So the start is one of those projections. The end of this is going to be, you see that we have this start projection, so we're going to give that to the start move. Okay, so that's going to be start and start moved, and then we have the direction. So I'm going to give this a Z direction, so this can go in the Z direction, and that's the direction tangent at the start. And here we go. So we have this, and we have to produce two of them for each of those segments. So if this is the segments, we have one here and one there. So again, let's just make another one. The start now goes to the end of this, and the end is the end of the moving thing. And I think that I just gave this wrong. Let's just make this from scratch. The start is going to be the projection of that start, the end, excuse me, we use that start. Now we have the end. This is going to be a little confusing, but I guess that you have to slow down the video to learn that. Okay, we have now the end at the start, then we have to use the end which we moved in the Z direction at the end, and the direction is again Z, and here we go. So remember, when we bake this, we have to have two arcs, and that is because one of those is going to go for, okay, this segment, and then when we go to this segment, we have again this one and this one, so this is going to be 2 times, and that's it. So now we made the arc, these two things, and now we have to make this one. Okay, so let's just get to the confusing part and make this one. Okay, to make this, I'm going to go to the spline and use an interpolate tool. And why I'm going to use this is because interpolate has a tangent. And if I just open this, you can see that we can have a tangent at the start and tangent at the end, and we can just have this at the start and at the end and produce that something like this. So here we go. The vertices, the degrees, tangent start, tangent end, and that's not really important. Okay, so the vertices, we have the start and the end, and we need another point here, so we can just make this down. And what I'm going to do is to produce a line here, extract the center, and move this down. Okay, you can do this in another way, doesn't really matter, but I'm trying to show you. You can also just move the center of this up and use that as the vertices. So remember, there are many ways you can do this. I'm just showing you how you can work with that. Okay, so let's just connect the line from the start and the end. We just moved up, give the center of this, and move them down in the Z minus direction. So I'm going to give this, we can play with this if we want. We can just move it down and up. That's going to give us a new Confluence Park. So if you want, you can just make this maybe from 5 to, okay, from -5 to 5 with 2 decimals, and this is going to be cool because we can also move this up and down. Okay, just turn this off and turn the line off, and here we go. So we have 3 points. To produce those vertices, what we have to do is to put these 3 points in one group, again these 3 points in one group, and so on. So what I'm going to do is to give these vertices into groups of 3. How can I do that? Let's just give this a point. We had this start and the end, so let's just put these in a point tool so we can understand this. Another point at the end and another point at the center. Okay, I'm going to bring this start, center, and the end, and now I'm going to make a group of 3s, and the technique is to use the graphed technique. I've explained that in the Grasshopper course. For those who have just entered the or subscribed to the course, they can watch the graphed section, or just watch the data management section. And if we graphed all of these 3 set of groups and put them into point, you can see that we have groups of 3, and that we can give this to the vertices, and you can see that it's producing this. But now the most important thing is the tangent at the start and the end, and we have that. The most simple step you can use is to use the line, that is the tangent. So what I'm going to do is to connect a vector to the line. That will make the line into a vector, and then we have to use this. Is if I give this to the start and the end, you can see that this is really big. So what I'm going to do is to, because this is the vector of the start, that is really big, so I'm going to use a unit vector to make this a 1 length vector, and let's just give this to the start and the end has to be minus that, so let's just give this a minus x. Okay, and the problem is that this is into 4 groups of 3, and as you can see, these are not in groups. So what I'm going to do is to graft these and this one. You can see that this is probably, okay, that's wrong, so perhaps this is the x and this is the minus x. I think just gave this wrong direction. So this is the x, and we don't need a minus x. That's cool. So I'm just going to delete this. It just understood that it has to have the direction is right, and you can see here. And what we can do here is to multiply this in the math section and give this a multiplication if we want a more bigger tangent. So check this out. You can see that's going to make a bigger one, so I just stick with that, maybe 1. So let's just stick with 1. It's okay, and you can see that we can just move these points up and down and always have a simple tangent at the start and the end, and we are good to go. That's it. It was a long tutorial, but we just finished that, so let's just do this. We have to use a sweep 2 because we have 2 rails. This is one of our rails, and this is one of the second rail, and the sections are this one and this one. So here we go. Let's use a sweep 2, and remember we have to have them in groups because each of those rails are going to be for one of those sections, so be sure to have them in groups. So the first rail is those arcs. Remember, if we give them here, we have to, you can graft here or graft here, doesn't really matter, so I'm gonna give the graft here. So we have them into 5 groups. Okay, the sections, one of those sections is this arc, so we have them here. Let's just put this in on a curve, and here we go. Again, if we want to make a group with 2 sections, we have to put them into we give this simple curve. If I just put them into one curve, we have to have group of two. And you can see we don't have a group of two because this one is graphed and this one is not grafted. So I'm going to give this a graphed. Again, check this out. You can see that those are groups of two. So each of those two sections are going to follow the correct rail. Okay, so let's just check this out. And this is the second one. Okay, first I just chose this, then this one, and you can see that's wrong because this is the first section and this is the second section based on the arc we just gave here. And here we go. You can see that this is amazing. We can just make this more height. Let's just delete this. We can change the height. We can change this from minus to plus and make us a new one. That's crazy. It's a new Confluent park. And the next step is to change the base polygon. Just check this out. This is crazy. It's giving you different results. And we can also change this size. Okay. So let's just take this back. Okay. So if I just polar array this, let's just do this. Polar array at the center, the number is 4. You can see that this is just completely correct because we have this tessellation and we can change the size. We can change, okay, excuse me, so I'm just changing those really fast, but I want to show you in a quick tutorial. So you can see I can change the circle and we can also change the height and we can change this. This is a new Confluent park, so that doesn't really mean anything, but we just go take this down. Okay, so the last part is if you look at those pictures, you can see that there's a little gap there. So how can we make those gaps? The best thing we can do is to, let's just delete this. What we can do is to make an offset on the surface. So I'm going to connect a curve to this, and this will just simply extract the borders of this surface. You can see these are the borders, and now I'm going to just offset. Let's just go for the offset on surface, offset this curve on this surface, and just define the distance, maybe 0.5 to 1.8. I really don't know, but let's check this out. We can give this a simple offset distance, and we're good to go. Okay, that's enough. And now we can just split that surface with this border. So I'm going to go to the intersection menu and in the physical section, and here we go, the surface split. We can split that surface with this offset curve, and we have two segments. One is inside this and the outside. So I'm going to use again the list item to see we have this as the inside and the outside. Let's just turn this off, and here we go. This is the resulting surface. Turn everything off. Let's just turn the curve also off, and here you can see that I can simply offset this as much as I want. Maybe we can just decrease that to 0.2 to have the smallest gap. And again, if you array this polar array at the center with 4 count, we have that exact gap as you can see here. And this is really cool because you can just have this. And you can again array this at that corner, at the corner which was 90 degrees. Again, let's just do this. Array this, and we need the point at this corner. Let's just go back we use the explode that polyline, just delete that. So let's just do this. Explode the rotated polyline, and we use the vertices 0, 1. So I'm going to give this a 1 and connect this to the plane. We have this 4 times. So this is a complete model, and you can just make this change. Let's just turn everything off. Here we go. We are ready to just change this. Change the size. We can change the rotation here. I think 30 degrees is a great one. So maybe have this results. We can change the height. And here we go. Okay, so let's just bake this. And you can download this definition from the website. Let's just put this into shaded. And here we go. If I go to the top view, you can see we have this base one here. Okay, the neighbor, we have to delete this one. So let's just check this out. From the top view, if we put this as the base one, this one is going to be deleted. Okay. The next step is to go for this model and just have the 2 top. So we have to delete these 2. Okay. Again, this neighbor has the 3 top. So this neighbor has the 3 top. Okay. And this neighbor has the 3 top. So we can just make, okay, we don't need these ones. So we have these 3 top. Let's delete them. We don't need these groups. Okay, so this was the base. This has the 3 sections, and let's just check this out. Again, this one is just a simple 1 to the edge. So if we had this here, this is it. We can delete that. I don't think we need that. Okay, so this is it. Then we have a 1 to that base one. So let's just go delete these ones. And then we have these 2 here. So these are the 2. Let me just check this out. Yeah, this edge and this edge. So this edge and this edge, delete these 2, and we're good to go. We have 1 here, just simply, I just delete that, I think. Now let's just do this with a mirror maybe. I just want to show you that you can exactly model this, but here we go. Okay, that's it. If you really want the exact Confluent Park, these are the sections, and let's just go to the rendered and see this is the results. We can just simply put a box here. Let's just turn the sun on. You can go on the, okay, you can go here and click on this and go to the sun, and let's just turn sun on. Just change this. Okay, so here it is, and you can see that we can also make these with Grasshopper. Maybe we need to just choose them with list item, but that's not really important. I want to show you how you can make the Confluent Park with Grasshopper, and here we go. You can see this is a long tutorial, so hit the like button and subscribe to our channel. Thank you for watching our videos, and comment on this video and give us your feedback, and thank you for watching.